Hello students and welcome in the online session of class 9th Science chapter 3 Atoms and Molecules. Today's learning targets are: what is an atom, how big or small the atoms look like, Dalton's symbol of elements, then modern symbol of elements, and how do the atoms exist. Then let us start with what is an atom. So, there are two definitions discussed here. So, the first one is that the smallest particle of an element which may or may not be capable of free existence is called an atom. So, how can we define atom? That atom is the smallest particle of the element, and this smallest particle may or may not exist freely. Okay, it can exist freely, or in some cases it may not exist freely. So that smallest particle of an element is called the atom. And the second definition says that the smallest particle of an element that takes part in the chemical reaction is called an atom. Okay, so the smallest particle of an element that takes part in the chemical reaction as a reactant is called as an atom. So these are the two ways to define the atom. Now let us see some examples of atoms. Now there are various elements whose smallest particles are called the atoms, like helium. Okay, so there is an atom of helium, then an atom of argon, atom of neon, atom of krypton, okay, xenon. They all are unreactive gases. Fine, helium, argon, neon, krypton, xenon, they all are gases, and these are called the noble gases as they cannot react with others. They do not react with any other element, and because they are unreactive, they do not react, so they exist in free state. Okay, as we have discussed that this smallest particle may or may not exist freely. Okay, so now this example of helium, argon, neon, they all are unreactive, they do not react with the other elements, hence they exist freely. Okay, so only that atom can exist freely which are unreactive. Unreactive means which do not show any kind of chemical reaction with the other elements. Okay, they can only exist freely. Others, those who are very reactive, they react with the other elements and then they cannot exist freely. Then they are found in the form of compounds. Okay, so let us see the example of that also. Now see, atoms of hydrogen, oxygen, nitrogen, they are highly reactive. Okay, highly reactive means they immediately react with the other elements, and this is the reason that they do not exist in free state. That means they are not found alone, because they are very reactive, they immediately combine with the other elements. Fine, so they do not exist in the free state. So they are always found in the combined state with the atoms of the same element or with the atoms of the other element, right? Like, suppose this is hydrogen. Okay, so we are saying that hydrogen is very reactive. So what the hydrogen will do? Hydrogen will react now. So hydrogen can react with other hydrogen atom also, and it can make H2 gas. Fine, so this hydrogen element, this hydrogen atom can combine with other hydrogen, means they can combine with the same element also, or they can combine with the atoms of other elements also. Like this hydrogen can combine with an atom of chlorine. Fine, and they will make a compound which is known as HCl. HCl means hydrochloric acid. Fine, so an atom of an element can combine with the same element also, or they can combine with the other elements atoms also. Like hydrogen can combine with hydrogen. So this is the example when the same type of elements are combining together. Or this atom can combine with the atom of another element. Like another element is chlorine here. So one atom of hydrogen and one atom of chlorine can combine together to make HCl. So they can found in any of these forms, in any of these compound forms. Okay, now for example, let us discuss some examples now. So you can see here dihydrogen. Dihydrogen means H2. Di means 2. Okay, so hydrogen can exist in this format. Oxygen can also exist as dioxygen. Dioxygen means 2 oxygen, so O2, which becomes oxygen gas. Then nitrogen can also exist, means 2 nitrogen, N and N will combine and they will make N2 gas. nitrogen gas. Okay, or so they are combining with the atoms of the same elements. Okay, now they can combine with the atoms of different elements also, like one example I gave you about HCl. Okay, another example you can see here of water, right? Like two hydrogen atoms can combine with one atom of oxygen and they will make water compound. Or you can say ammonia. Ammonia formula is NH3. So here you can see that one atom of nitrogen combines with three atoms of hydrogen and they form NH3. That means ammonia. NH3 is the formula of ammonia. So side by side you have to learn the formulas also. Okay, this is hydrogen gas formula. This is oxygen gas formula. This is nitrogen gas formula. This is the formula for water. This is the formula for ammonia. Okay, ammonia is a poisonous gas. Fine. So atoms of one element can combine with the atoms of the same elements, or they can combine with the atoms of the different elements also. And in this way, they are found in the combined state in the nature. Okay, and some can be found in free state like the noble gases which are unreactive. Okay, unreactive ones can be found in free state, otherwise rest all which are reactive can be found in the combined form. Now here in the diagram you can see, now this is the diagram of an atom of an element. Okay, so this is an atom of the element. Now here you can see that two atoms have combined, but you can see that both the atoms are of same color. That means both these atoms are of the same element. Suppose this is also an atom of hydrogen, this is also an atom of hydrogen. Fine. So when the two atoms of the same element combine together, then they make a molecule. When atoms combine together, they make molecules. Okay, and now because both the atom are of the same element, so we call it as the molecule of an element. Okay, we call it as the molecule of an element. Fine. When both the atoms are of the same element, then we call it as a molecule of an element. Now in the third diagram you can see here that this one atom is of different color and these two are of same color. Okay, that means what is happening, two different type of atoms of the elements are combining. Here you can see that both the atoms are of same element, but here you can see that two different elements are combined. Okay, suppose these two dark shaded ones are of hydrogen. Okay, and this one is of oxygen, so it becomes H2O. Fine. So two different type of elements are combining here. One is hydrogen, other one is oxygen. So this is also a molecule, but now this is a molecule of a compound. Now this is a compound formed here. Okay, molecule of a compound. This is molecule of an element because same elements were combining. So this is also a molecule, but molecule of an element. Now when different elements combine together, then it becomes molecule, but molecule of a compound. Now this is the difference you have to remember here. Okay, if same elements are combining, it forms a molecule of an element. If different elements are combined, they form a molecule of a compound. Okay, I hope this is clear. Then now, how big the atoms are? Can we see the atoms? Now this is the question, right? So atoms are very small particles. Okay, atoms are very, very small and they cannot be visible with our naked eyes. So we have to use a microscope to see those invisible atoms. Okay, recently a highly sophisticated microscope which is known as scanning tunneling microscope. Okay, I repeat, scanning tunneling microscope, in short, which is called as STM. The picture is also shared here of scanning tunneling microscope, STM. So this has been devised which has made possible to take the photographs of the atoms. Okay, so this is the device which is used to take the photographs of the atoms and through which the atoms are clearly visible. Now, as atoms are considered to be spherical, their sizes are expressed in terms of their radii called as atomic radii or atomic radius. This radii is the plural word, singular word is radius. Okay, so atoms are generally spherical in shape, but they are very, very, very small and the radius of their circle is called the atomic radius. Okay, suppose this is the atom. So this is at the center, there will be nucleus, right? So from the center of the nucleus till the last orbit, so this distance is called the atomic radius. Now radius of atom is usually expressed in nanometers. Okay, so the unit which is used to measure the atoms, it is nanometers. Okay, N stands for nano and M stands for meter, so it is nanometers. Now 1 nanometer is equal to 10 raised to minus 9. Okay, 10 raised to minus 9 meters. Okay, means 1 nanometer is equal to 10 raised to minus 9 meters. This is the relation. Or you can say 1 meter is equal to 10 raised to power 9. But I think this one is better to learn, that 1 nanometer is equal to 10 raised to the power minus 9. Okay, 10 raised to minus 9 is called the nanometer scale. So this much small is the particle or the atom sizes. Hydrogen atom, which is the smallest of all the atoms, has the radius of 0.037 nanometers. This is the radius of the hydrogen atom. So it is this much small. Fine. So you have to remember that the radius of the atom is measured in nanometers. 1 nanometer is equal to 10 raised to minus 9. And hydrogen atom is the smallest among all the different types of atoms, and its radius is 0.037 nanometers. And STM, scanning tunneling microscope, is the microscope which can take the photograph of the atoms. Now next is Dalton's symbol of elements. Now first of all the atomic theory was given by Dalton, as we have discussed in the previous video. So Dalton has also given some symbols for identifying the elements, right? Like hydrogen, symbol of hydrogen is there is a dot in the circle, so this symbol was representing hydrogen. Completely black darkened circle represents carbon, empty circle represents oxygen, and here you can see the different other symbols of the elements, right? You can see here iron, how the symbol looks like. I is written in the circle, then for copper C is written in the circle, for silver S is written in the symbol, right? For gold G is written along with some pokes lines in the circle, so that is the symbol of gold. For lead L is written, and for mercury you can see some design is made in the circle. So in this way, Dalton has given different symbols of the elements. Okay, so there is no need to learn this, only for your information, that nowadays we use some specific letters for symbolizing the elements. Like when we write H, this is the symbol of hydrogen. When we write O, this is the symbol for oxygen. But previously, some symbols, different symbols were made for identifying the elements. Now let us discuss some modern symbols of the elements. So the symbol of an element is the first letter generally, or the first letter and another letter of English name, or the Latin name of an element. Okay, so every element which is present in nature has a Latin name, the name which is used in Latin language, and one English name is also there. So whatever symbol is used, that can be the first letter of the English name, or it can be the first letter of the Latin name of that symbol, right? Like for iron, what is the symbol used for iron? It is Fe, because the Latin name for iron is ferrous. Okay, for hydrogen the symbol used is H. You have to learn these symbols. Okay, for copper the symbol used is C capital and U small. Cu is the symbol for copper. Latin name for copper is cuprum, so it is Cu. For carbon the symbol used is capital C. For gold the symbol used is Au. Fine. So these symbols you have to remember now, because this is the modern technology or model symbolization of the elements. Now, sometimes you have seen that there is a single letter used, and sometimes two letters are used for symbolizing the elements. Okay. So now this second letter which is used, it can be the very second letter from the first one, or it can be any of the middle letter from the name. right? Like copper symbol is Cu. So you can see here that Cu are the first two letters of the word cuprum. So Cu is used. For lithium, you can see that the first two letters are the symbols. For barium, the first two letters are the symbols. For gold, now gold is the English name, but the Latin name is aurum. So Au, first two letters are the symbols. Okay, but for mercury, you can see here the Latin name for mercury is hygram, but the first two letters are HY, but HY is not the symbol for mercury, it is Hg. So in many cases first two letters are used as symbol, or the first letter and any one of the letter from the middle can also be used for symbol, right? Like tin symbol is Sn because Latin name of tin is stannum. Okay, so stannum Sn is used as symbol for sodium. Name is natrium and Na is the symbol for sodium. So you have to learn these symbols, okay? Especially the elements which are used again and again like iron, hydrogen, copper, carbon, okay, mercury, potassium, antimony. If you'll not do, it's okay. Sodium you must know, lithium you must know, copper you must know. Okay, so some 815 elements you must know their symbols, which are used again and again in your chapter and in the chemical reactions which come as examples. Fine. Now there is no need to learn their Latin names, only you have to learn their English names as well as the symbol used to identify these elements. Now, the next is modern symbols of the element. Okay, so you can see here symbol for gold is Au, symbol for silver is Ag. All these tables are given in your textbook also. Then for mercury it is Hg. Then for copper it is Cu. For lead it is Pb. For iron it is Fe. For sodium Na. Potassium K. Tin Sn. Okay, for magnesium it's Mg. Aluminium Al. Calcium Ca. Chromium it's Cr, manganese Mn, cobalt Co, nickel Ni, zinc Zn. Okay, and all these others for hydrogen H, nitrogen N, oxygen O, fluorine F, chlorine Cl, bromine Br. Okay, so you can learn these symbols from your book. And there are some pictures also given. This is the picture of gold, this is for silver, this is sodium, okay, this is the form of carbon, and this is arsenic element. Okay, so you have to learn these symbols of the elements. Okay, without learning the symbols it will be very difficult for you, because whenever we are writing, we generally write the symbol of the element all the time. We have not to write their complete name, we can just write the symbol and it will work. Then next is, how does the atoms exist? Okay, so atoms exist either in the combined state with other atom of the same element or with the atom of the another element. Okay, and when they combine they form molecules. Okay, so in the previous one of the slide I have shown you that molecule of an element and molecule of a compound. Okay, so when the atoms of the same element combine together they make molecules of an element, and when atoms of the different another element combine together they make molecules of the compound. Okay, but it is very true that when atoms combine together they make the molecules. In detail you will study about these molecules in the next video, but this much you have to remember. Now you can see here a picture of a very big molecule. This is complete one molecule, and the name is written here, it is 137 trimethyl enthene. Okay, so this is the name of this molecule, it's a very big molecule. So you can see here different types of elements are combining together in different ways to make this complete molecule. Okay, no need of learning this molecule, this is just to show you that how much big the molecules can be. Now here you can see the different atoms of the elements. Here you can see a molecule formed, and atoms also exist in the form of ions. You can see here that magnesium has got a charge of 2 plus. Okay, it has got a charge of 2 plus. So this is the ion. Ion are the charged molecules, okay, charged particles which have some charge either in plus or minus. 1 plus, 1 minus, 2 plus, 2 minus, okay, 3 plus, 3 minus can be. So positive and negative, both the charges can be there. So charged particles are called ions. Okay, they are called ions. So atoms can exist freely or in the form of molecules, or they can also exist in the form of ions also. Okay, so you will learn these concepts later in the chapter one by one. Now you have to study about atomic mass and atomic mass unit. Okay, so every atom has its mass. So mass of an atom is called the atomic mass. Okay, atomic mass is the mass of an atom, and this mass is measured in a unit which is called AMU. AMU means atomic mass unit. Its abbreviation is AMU. Okay, like length is measured in kilometers or meters, weight is measured in kgs or grams. Likewise, atomic mass is measured in atomic mass unit. AMU is the unit of the atomic mass. Okay, here in the second line you can see that AMU is the unit of atomic mass of the atoms. Now, what is atomic mass actually? Atomic mass of an element is the relative mass of its atom as compared with the mass of an atom of carbon 12. Okay, like see, for measuring something, we take some standard measurements, right? Like when we take the measurements in kg, so we know that 1 kg is equal to 1000 grams. Okay, 1 kg is equal to 1000 grams. So this is one standard unit. This is one standard unit which is used. Likewise, now AMU, atomic mass unit, is the standard unit to measure the atomic mass. But what does atomic mass unit means? Okay, like we know that what is the meaning of 1 kg? 1 kg is equal to 1000 grams. In the same way, what is atomic mass unit? Okay, so 1 AMU or 1 atomic mass unit is 1 upon 12th the mass of carbon 12 isotope. Here the standard mass of an element is taken, that is carbon 12. Okay, carbon 12 is taken as the standard atom, and all other masses of the other atoms of the elements are measured by taking carbon 12 as a standard mass. Okay, so mass of the carbon 12 is taken as a standard, and all the masses of the different elements are found by using the mass of carbon 12 as the standard format. Okay, so 1 AMU has a particular value. Like here in the next slide I have written 1 AMU is equal to mass of the carbon 12 atom divided by 12. So this value is known as 1 AMU, and if we have to find the value of AMU in kg, then it comes to 1.66 multiplied by 10 raised to minus 27 kgs. This is the value of 1 AMU in kgs. Okay, I repeat again, 1.66 into 10 raised to minus 27 kgs. Okay, and 1 AMU in other format we can write that when the mass of carbon 12 atom is divided by 12, then this value comes to this value, and this is equal to 1 atomic mass unit. Fine. So you can see here 1 AMU is equal to 1 upon 12th the mass of the carbon atom. Okay, 1 upon 12th into the mass of C12 atom. What I have shown you just now, that C12 mass of the C12 atom upon divided by 12, that comes to the value of 1 AMU. Fine. So you must know that atomic mass is of every element is measured by taking carbon 12 as a standard element. Why only carbon 12 is taken? Because carbon 12 atoms are found abundantly in nature. Okay, carbon 12 atoms are found in plenty in nature. Abundantly they are found in the nature. Everywhere they are found in the nature, and that's why carbon 12 is taken as a standard format. Okay, standard atom, and the mass of carbon 12 is 12 only. Fine, 12 AMU. The mass of carbon 12 is 12 atomic mass unit. So this is the standard pattern set. And then you can see here in the table also that the atomic masses of the different elements are given. Okay, so you need not to find the atomic mass of each and every element using the formula, but you must know the definition for what is atomic mass. That atomic mass is the relative mass of an atom, which is found by comparing it with the mass of carbon 12 isotope of carbon. Carbon 12 is an isotope of carbon because there is carbon 14 also. Okay, so all the masses are found by comparing it with the mass of C12. And here in the table, you can see here the atomic masses of different elements. Like for hydrogen, the atomic mass is 1. For helium, the atomic mass is 4. For lithium, atomic mass is 7. Now, all these you have not to learn, but the common elements which come again and again, like hydrogen, helium, okay, sodium, magnesium, aluminium, carbon, nitrogen, oxygen. So these much, I think 8 10 elements are very important, which will come again and again. So that much atomic mass you have to learn. Okay. Now, if there are isotopes, fine. Like chlorine has two isotopes. Chlorine 35 is also available and chlorine 37 is also available. Right? That means there the chlorine atom whose mass is 35 AMU is also available, and there are some chlorine atoms whose mass is 37 AMU. Right? Like if I give you example, like there are two tomatoes in the market. If you go for buying vegetables, you'll find tomatoes. Like both are tomatoes, like both are chlorine, so both are tomatoes, but the weight of tomato 1 is different and the weight of tomato 2 is also different. So the same case is with chlorine. Okay, so there are two different atoms of chlorine. So mass of one chlorine atom is 35 AMU and the mass of another chlorine atom is 37 AMU. Right. Now both of these chlorine atoms are found in nature, but more ratio is of chlorine 35. Okay, so what ratio they are found? They are found in the ratio of 3 is to 1. Okay, if three atoms are of chlorine 35, then one will be found of chlorine 37 also. So they are found in the ratio of 3 is to 1. Then how to find the atomic mass of chlorine now? Because there are two isotopes of chlorine. Okay, so we cannot say that all the chlorines have the mass of 35 AMU, or we cannot say that the mass of all the chlorine atom is 37 AMU. So now what we will do, children, now we have to find the average relative atomic mass, right? And how to find the atomic average relative atomic mass? Now see the formula here. Now see, this is the mass of first chlorine atom, that is 35, and it is 37. Why we have multiplied it with 3? Because ratio, it is given in ratio is 3 is to 1. Okay, so three atoms are of what, which chlorine? It is of chlorine 35, right? So we'll multiply 3 with 35. One atom is of chlorine 37, so 1 is multiplied by 37 and added. For average, we have to add, right? And why we are dividing it with a 3 plus 1, that is this ratio. So we have to divide it by the total number of the atoms, right? So means if there are total 4 atoms, then out of 4, 3 are of chlorine 35 and 1 is of chlorine 37. So the total addition of the ratio is taken as denominator, and 3 are of 35, so we will multiply it, then plus 1 is of 37, so we'll again multiply them, and in between there is a addition sign. And when you solve this out, you will get the answer 35.5. That means the average atomic mass of chlorine is 35.5. Whenever you have to use this value, average value, because there are two isotopes of chlorine. Okay. Now, so this we have discussed that in kg, if we compare 1 AMU with kg, so 1 AMU is equal to 1.66 into 10 raised to minus 27 kg. And what is 1 AMU? 1 AMU is the unit which is found by dividing the mass of carbon 12 by 12 only. Okay, mass of the C12 atom with 12. So then we'll get this value, and this is equal to 1 AMU, atomic mass unit, and this is the unit of atomic mass of an atom. Fine. You need not to find with any of the formulas. You have to just learn the atomic masses from the table, and the definition must be learned to you all. And you must know what is AMU. AMU is the unit of the atomic mass. Okay, so this much you have to learn from here. So we have come to the summary. So what we have learned today, we have learned that what is atom? Atom is the smallest particle of an element which may exist freely or may not exist freely, and which takes part in the chemical reaction also. Then how big the atoms are? Atoms are very very small in size. Their atomic radius is measured in nanometers. We use STM microscope to visualize these atoms. Okay, and 1 nanometer is equal to 10 raised to minus 9 meters. Fine. Then Dalton symbol of elements you need not to learn. You have to learn the modern symbol of elements. So some of the symbols which are very commonly used, you have to learn them. And then we discussed about the atomic mass. Atomic mass means mass of one atom of the element. It is measured in AMU unit, atomic mass unit. And atomic mass unit is found by taking C12, carbon 12 isotope, as a standard measurement. Okay, and in kg it is equal to 1.66 into 10 raised to minus 27 kgs. So this value also you have to learn. Fine, so this much we have covered in today's video session. I hope this is clear to you all. Please read the lesson till here from your textbooks also, so that it will be more clear to you, and we'll meet in the next video session. Till then, all of you stay home and stay safe.